Hello, LKruse here, doing my article review on development of the key pecking pause and ambulation during extended exposure to a fixed interval schedule. Article is from 2012 by Barry, Kangas, and Branch. It was published in the Journal of Experimental Analysis of Behavior. What really the researchers were looking at was trying to develop a more complete characterization of the development of performance across the fixed interval exposure. So that's really what kind of the overall purpose was. It's been shown, the scalloping effect that we see due to that post-reinforcement pause. All the previous research looks at kind of the different variables that have been studied, so long versus short intervals, extinction effects, variation on the reinforcement percentages, what happens when they've been exposed to other schedules prior, overall stimulus control and temporal control, so are they able to tell how long the interval is, and what types of pharmacological effects are there as well. What these researchers were really looking at was using a VI schedule. They did a VI schedule 3. And how does that affect the following, the rates of pecking behavior, the pausing, so that post-reinforcement pause, and ambulation, which is a behavior that has been observed during kind of those intervals of another behavior that the subjects, pigeons in this case, are engaging in addition to the pecking. And what really they wanted to look at was what do we see over an extended exposure? So instead of just a short experiment, over an extended exposure. So they did 200 daily sessions. So 200 days, they did a session each day. And they also wanted to look at different criteria for stability and how long does it take stability to occur, how do you measure that stability, and how valid are those stability measures. The subjects were 6 male white Carnu pigeons that were experimentally naive, about a year old, and they were kept at 85% of their free-feeding weight. The apparatus was pretty similar to most of the other studies, an operant conditioning chamber with a circular key. The kind of main difference that this study had was the floor panels were designed to detect where the ambulation, so where the wandering was occurring, and needed a certain amount of force to happen on each panel so that it could say that the pigeons had moved over to this panel or that panel. And so they did pre-training, of course, on how to eat from the hopper, how to key peck when the key was illuminated, etc. The dependent variables that they measured were the response rate, so number of responses per minute, and then over the session. The post-reinforcement pause, so duration from the start of the interval until that illumination, what was happening. And then ambulation counts, so the number of panel presses within a session per panel. For stability, they kind of looked at stability over those three things and used the following criteria. So criteria 1 was just visual inspection. So can we see these trends by visual inspection? Criteria 2 looked at if you take 2 consecutive 10-session blocks, were all those 2 blocks within 10% of the average? So if you're looking at 2, or how different are they really? Criteria 3 and criteria 4 were similar. One did 3 7-session blocks and looked at the average of all of those. Was there more than a 10% variation? And criteria 4 was similar method, but for 3 blocks instead of 7 blocks. For the procedure after the pre-training, they did 2 basic sessions just at a VR1 just to make sure, kind of get everything baseline stabilized. And then they started an FI 3-minute reinforcement schedule for the remainder. They did do a 5-minute blackout period at the start of each session just for kind of acclimation and kind of reset things. So in total, they did 200 total sessions, 1 per day. Each interval there's 15 intervals per session plus the 5-minute blackout period. So 15 3-minute intervals plus the 5 minutes was 50 minutes total per day for 200 days total. Here's the summary of the key pecking results. So every column is a particular session, so a particular day. So day 1, day 5, 50, 100, 200. And then the rows are the different subjects as well. So you can see the 11, the 63, 637, 750, 849, and 884. And then each individual graph is showing the average number of responses with the standard deviations for 10 successive 18-second intervals over that FI3. So what this graph overall is being able to show you is that scalloping developing. So in sessions 1 and 5, results are pretty consistent across. There's even in the very, very beginning an initial higher rate at first. And then right around session 50, you kind of start seeing that scalloping pattern develop of lower responding in the beginning and then it increasing over that FI3. And by the end, there's kind of that consistent pattern throughout. The key pecking results, so as we said, initially more of the pecking was seen at the start, but by kind of you start seeing it at the 5th just a little bit. The traditional scalloping is seen more and more. And then by the 50th session on, it was clearly visible through at least the visual analysis. So this then leads you to the next question, is what is causing this scalloping? And there's kind of 2 theories that they propose, that it's merely a symptom per se of that post-reinforcement pause. So it has to do with that prior reinforcement. The other theory is that it's really showing that developing knowledge of kind of the temporal concept so that they can understand that, oh, the interval is about this long, so there's no point in me pecking in the beginning because there's no chance of me getting reinforcement. So starting to really understand that time concept. Post-reinforcement pause results kind of summarized. So they did what is called autocorrelation coefficients. So how similar the prior post-reinforcement pause was to the next one. A number of 0, so the range is -1 to +1. A 0 means that they were the same, and so the negative and positive means that there were variations. And so what they were trying to look at is, does that change over session blocks? And so in the beginning, there was kind of a mix of the positive and negative, where sometimes it was longer beforehand, sometimes the one after was shorter. And so if the interval beforehand was shorter than the next interval, you kind of see that negative over the session. If it was longer, you see that positive. So it's mixed in the beginning. And then you start seeing many more negatives, which means overall the interval prior was shorter. So in the first couple sessions, there was that mix of positive and negative. So initially, we couldn't really even predict that what a prior reinforcement pause could not predict the following one. More negative are seen. So there was probably that alternating with short and long durations. There was not a strong pattern seen, but there was a trend at least seen when you compare the first couple sessions where there really wasn't any consistency to the end sessions where there was more. For overall ambulation, so they're kind of moving about behavior for the 20 session blocks. This is what it's looking at, each 20 session block with a pigeon. Where were they stepping? And was it during the during the pause, which is your DP column, or was it after they started pecking? So the AP. The results of that show there was lots of variation seen in frequency. At the end, by kind of in total, by the end, 4 of the 6 pigeons showed more during the post-reinforcement pause than after. And overall, across the board, there was a general decrease in movement from the first session to the 200th session. The location was what they found was really interesting. Was they tended to stay on the panels farthest from the chamber door, as well as kind of the key was in the middle, so there was kind of the key would be between panel 3 and 4, say, and then say the door was at 1, they tended to stay at 6. And that remained fairly consistent. There was some discussion on, is it really the furthest from the door? Is it also furthest from the key? Or are both of those factors relevant? So there's stability analysis, what they then looked at, looking at the response rate. So just using visual analysis. Stability was seen more during the second 100 sessions overall. So that variability we saw lessen is what they really looked at. Using criteria 2, the variability of 10 session blocks, everyone met criteria within the first 40 sessions, and then majority met it as well after, but it wasn't consistent. And this was kind of seen across the board. So 3 and 4, same thing. Many of them hit stability criteria, but they were not able to maintain that stability criteria. So even though they met it at one point, it did not continue throughout the remainder of the 200 sessions. Very similar results seen from the post-reinforcement pause. The criteria 1 overall showed an increase in the post-reinforcement pause across the sessions for most of the pigeons. And then for criterion 2, 3, and 4, it was very similar. Once the criteria was met, usually we're kind of by that 40 to 50 range session, but it was not maintained. So the authors kind of picked 3 big notable results that they felt their study really showed. One was that response rates seemed to stabilize prior to the post-reinforcement pause. So 2 is that stability criteria designed for slow trends were more accurate in identifying the stability, but there was still a lot of variation. And then ambulation showed high variability with higher overall average ambulation during the beginning. About 67% of the time it was higher during that pause than after. So let's look at each of these a little bit more. The response rate versus the post-reinforcement pause. So stable response rates were observed by the 100 session for 5 of the 6 pigeons, compared to the post-reinforcement pause, which continued to increase. In some of them, even as much as 50% from the 100 session to the 200 session. So we saw that pause increase more and more. So perhaps they were getting better temporal control, they understood the time interval, or as discussed before, is that just the symptom of now they're even reaching kind of more comfortable with the pattern, maybe satiated. So what does that mean for future research? So future studies that look at response rates, what really the stability part shows, they can do fewer studies than those that are looking at issues of temporal control. So because the temporal controls seem to continue to develop, you probably want to do more sessions, more trials with those type of studies than if you're just looking at basic response rate. For the overall stability criteria, basically one stability measure method doesn't suffice for all research. So criteria 1, the visual analysis is always a good method, but it's not necessarily as quantifiable, and there's a lot more variation sometimes between how different people look at it. Criterion 2 could be too stringent for some lower response rates, and 3 and 4, similar criteria 2, showed the initial stability, but it wasn't able to show consistent. So what does that mean? One question is, was behavioral stability not actually achieved? So perhaps more sessions needed to be done. And so are more sessions needed to achieve that behavioral stability for the post-reinforcement pause in particular? So future research really needs to consider, when they're looking at kind of stability measures as well, and doing valid research, are the number of sessions, the intervals per session, what the FI is, because if they're not able to get to a point where the data is really stabilizing, is that then truly valid? So for ambulation overall was highest prior to the kind of post-reinforcement pause being shown consistently. And once that temporal control was established, the researchers did not see any correlation really between the ambulation and the rate of responding or the post-reinforcement pause. So we saw overall trends with ambulation, but not consistent behavior. So for future research, what really is the function of that ambulation? Why was it occurring furthest from the door or from the key, or were both a factor? And are there other behaviors occurring during that post-reinforcement pause? How do those have an impact? So this is actually what I looked at for my research proposal project, and looked at, can you affect the ambulation and where the pigeons are moving during that post-reinforcement pause by using differential reinforcement measures. One theory that I came up with was perhaps they move furthest away as part of a checking for predators in the area. So if they go to a further key or further panel on the floor, kind of the outskirts of their area, and that allows for a predator or something like that to come and take some of their resources. So decreases the amount of food they can access compared to when they're closer. Would that affect their movement patterns? So basic run through, internal validity, things that they used to kind of help with the internal validity was using white noise to eliminate extraneous sounds, to kind of eliminate those other variables. They did do the high number of trials to kind of, and the stability measures to really try to confirm that that was there. They did not do any type of withdrawal, however. For reliability, they used mechanical data collection for pecking and ambulation, and they attempted to use formulas to show stability instead of just using the visual analysis. In external validity, they did show consistent development of the post-reinforcement pause across all subjects, but there was still a lot of variability within that and within the ambulation and some of their measures, even within a species. So definitely more research still needs to be done. And overall future directions, the post-reinforcement pause, how does changing that schedule of reinforcement affect it? So they did the NFI-3, but how does that schedule really affect that pause? So what if it was a variable? You don't see it as strongly, a longer one, shorter, kind of still more research needed on that. For stability measures, really there needs to be a lot more research on how do we truly define what it means for data to be stable, and using kind of a more concrete mathematical method. And for the ambulation is looking at why do the subjects use up energy to move far away from that reinforcement source instead of just kind of staying put. And there's the references. I hope you enjoyed my presentation, and everyone has a great rest of their day.